So hello everyone. Today we'll be going through the week 7 mini test from Spesh, and I'll just have all the answers on the screen first. So if you guys want to just check the answer, then go ahead. And okay, I'll quickly go through my working out for each answer. So for the first graph here, immediately we can tell the y-intercept is 2, 0 and negative 1, 0 by subbing y equals 0 and testing what x value would satisfy the y-intercept. So immediately we can graph. Let me actually switch to a red pen. We can graph this point here and this point in the graph already. And then we can also do the y-intercept, which we just let x equals to 0, and then that gives us 0 and 4. So this point is done. So since this is a cubic curve, it's a cubic curve. It will most likely have a local maximum and a local minimum. So we have to take the derivative of this graph and make it equal to 0. So the derivative of this graph after simplifying is this, and my working out is just here. And after making it equal to 0, we get x equals to 0 or x equals to 2. So the interesting part of this graph is that one of its x-intercept and one of its y-intercept is actually the local maximum and local minimum of this graph. So we don't have to do any more calculations. But in other cases, most likely they're not, and we have to work out the coordinates of other local maximum and local minimum and basically sub those in and graph them. But yeah, in this graph, we can tell it's because the shape is like this, then this point here has to be the local maximum, and this point here has to be the local minimum. Therefore, the graph will just look something like this. And make sure you don't forget the arrows at the end, because the graph is like continuous and we don't have a restricted domain. So this technically goes for infinity. So yeah, don't forget the arrows. Okay, for the next graph here, y equals to this part here. Excuse my terrible drawing and coordinate writing. So basically, when we know if it's a square root function, we would want to calculate the starting point first. And to calculate the starting point, we just let the inner part of this equal to 0. So we let 2 minus 3x is equal to 0, and we get x is equal to 2 on 3. The reason we do this is that if we sub in a value in this case, like for x that's bigger than 2 on 3, we will get a negative number, because when x equals to 3 on 3, this equation here equals to 0 exactly. So let's say if x equals to 1, which is bigger than 2 on 3, then we'll get negative 1, and we can't have a square root of a negative number. That's why the smallest x value in this case is just 2 on 3, and the y value is 2, because we're letting this inner part here equal to 0. Therefore, our starting point is just this point here, which has the coordinate 2 on 3 and 2. Then we can just work out the x and y intercepts. So y-intercept, we just let y equal to 0, and we get x equal to, y-intercept, we let x equal to 0, and then we get the y-intercept is 0, 2 minus square root of 2, because we're just letting this part equal to 0. And similarly for the x-intercept, we just let y is equal to 0, and we get x is equal to negative 2 on 3, and y is 0. So we can just plot these 2 points and connect the square root graph, and we're done. And make sure for this graph, we only have an arrow on one side, because this side is this endpoint. But this side, it goes like indefinitely, so we have to add the arrow here. Okay, for our third graph, it's from looking at this, we can tell it's a hyperbola graph, and we have to, or we don't have to, but I think it's better to put it into this form here so we can work out the horizontal and vertical asymptote easier. So to do that, we find the common factor of the denominator through the numerator. To do that, we see that the denominator is x plus 2. So we can put the numerator as 2x plus 4 minus 5. Notice this is the same as 2x minus 1. It's just we're just splitting the negative y into plus 4 and minus 5. And by doing this, we can factor on the top to be 2 times 2x plus 2 minus 5. And notice how this can just cancel out, and we get y equals to 2 minus 5 on x plus 2. So this step just becomes this step. And by doing this, we can immediately see the vertical and horizontal asymptote, because this will be a horizontal asymptote, which is x equals to 2. And by letting this equal to 0, the x value will be our horizontal asymptote. So x in this case equals to negative 2. Therefore, we have the vertical asymptote of y equals to negative 2, because x can't be, because this part here can't be 0, or this graph will be undefined basically. So, wait, actually, no, sorry, I just realized I made a mistake here. This is meant to be be y equals to 2. This is meant to be x equals to -2. Yeah, sorry, my bad. So that's the two asymptote for this graph. And then we can just work out the x and y intercept. So by this graph, we let x equals to 0, we get y equals to, so we get 2 equals to that, and we let x equals to 0, and we just get x equals to -1/2, which we can put that here, which is 0, 0, -1/2. So that's our y-intercept. And for our x-intercept, we just let y is equal to 0, and then we get x equals 1/2. So that's our two intercepts. And after getting these intercepts, we can just like put the graph together on one side and mirror on the other side, like that. Don't forget the arrows at the end. And that's the 3 graphs done. So for question 2, we are trying to work out the for what value of a would the intersection point of these two graphs have two distinct intersection points. So to do that, we first let the y equals, we'll make the graph equal to each other, because since if they're intersecting, that means x and y are the same value. And then recall the determinant from quadratics. If we have b squared minus 4ac is bigger than 0, we'll have two solutions. So in this case, which are equal to two distinct intersection points. So we have to rearrange this equation here in the form of this equation. And to do that, we just times everything here by x squared. I mean, not by x, sorry, by x. So we get a is equal to x squared plus 2x, and then it becomes x squared plus 2x minus a equals to 0. And now we take the determinant, which b is 2, so b squared is 4. And minus 4ac, so minus is -1. A is, in this case, 1. So -1 times 1 is -1. And c is -a. Therefore, -1 times -a is just becomes positive a. And then because it's 4ac, then it will be 4a here. So 4 plus 4a, we have to ensure this is bigger than 0, which means 4 is bigger than -4a. And that basically shows that 1 is bigger than -a. And now we have to times both sides by -1. And here's a really important step. Make sure that when we're timesing both sides by -1, we have to reverse the equals, like the inequality sign here. So we get a is bigger than -1, which we can pick up option D. And for the final question, I forgot to do the answer for this one, but so if you just want to here to check the answer, I'm pretty sure the answer is E. So so now I'll go through my working out for this question. So first we have y equals f of x, and it's transformed into y equals to g of x. So we can kind of see what's happening here. We're kind of halving the horizontal, the vertical length by a factor of 2. Because the maximum point is 2, but the maximum point of the transferred graph is 1. And we are doubling its width. So notice how the maximum point here is pi on 2, but the maximum point for g of x becomes pi. So in a way where basically for the vertical, it's a dilation factor of 1/2, and for the horizontal, it's a dilation factor of 2, basically. And since the vertical dilation is x-axis, because when we want to halve it, we just say dilation factor from x. So we would halve the graph by saying that. So we can see that E has this option. And for a horizontal dilation of 2, we can just say it's a dilation factor of 2 from the y-axis, because that makes the graph wider, right? Because we're talking about from the y-axis. So if we make the graph wider, see, if we call this a factor of 1, then if we make it wider, this will be a factor of 2, basically, from the y-axis. And that's why we can pick up E for the answer. But there's actually another thing to consider for this question. Let's look at question A quickly. So it says that we are taking a dilation factor of 2 from the y-axis, followed by a translation of 1 unit down. So let's do what question E is saying. So our original graph is something like this, right? And by dilating it from the y-axis by a factor of 2, it becomes something like this with its maximum at 2. So, and then if we notice a top point, if we translate by y unit down, yes, we'll also get this point. But if we really translate the whole graph down here by 1, then we would, this intersection point here at 0 to 2 pi, I mean, sorry, not, it's 2 pi and 0, would go down to 2 pi and -1, which it on this translated graph is still 2 pi 0. Therefore, there's no vertical translations that has been made. Therefore, it has to be E, and we pick up E as the answer here. If there's any questions regarding this worksheet, you guys can feel free to just add me in the WeChat group and I can explain further. And other than that, if you guys have time, you can also come to the study hub, which runs every Tuesday from 6:30 to 8:30, and I'll also be there to answer your questions.